All right. So for today, we're also going to be talking about complex numbers in our notes for today. Now, complex numbers, as you can see on the top, it says students are going to define and use imaginary unit I. So when we've started this class, we talked about real numbers. And just about every number, any number that you can think of, we said is considered a real number, whether it's positive, negative, fractions, anything else. But a complex number is basically a combo of real and imaginary numbers. Yes, we have fake numbers that exist out there. They are called imaginary numbers. But that's what a complex number is. It's basically a combination of two things, a combo of real numbers and, of course, imaginary numbers. And we can see that here in the graphic that we have. So notice, to be a complex number, it gets split up into two parts. That's why I said it's a combination of two things. So one, we have real numbers. And if you look at our list of numbers down here, this is every number we've been working with. We have decimals and fractions. We have decimals that don't repeat and never end, like pi. We've worked with that already too. We have positives and negatives when it comes to integers. And of course, our classic whole numbers and natural numbers that are basically positive numbers, and a zero for that one. The only new thing that we have that we haven't really dealt with these problems is this concept here of imaginary numbers. And when we're working with imaginary numbers, this is the new concept here. It says the imaginary unit I is defined by the square root of a negative number. Now, we brought that up the other day. We said, hey, in math, we cannot take a square root of a negative number and get a real solution. Well, yeah, now we can. Now we will be able to take the square root of a negative number, but we're going to need to make sure that when I do that, I bring out this concept of I. When I take a square root of a negative number, the I will come out. And it's that I that represents the fact that it's an imaginary number because we took the square root of a negative. But the only way to understand that is to actually see it right being used. The only other thing I wanted to mention, they never really gave us an example of what a complex number looks like. So here's some examples of complex numbers. So say, for instance, it says 3 plus 2i. Notice how it has a real component. And of course, because of the I, it has an imaginary component as well. That's what a complex number would look like for us. Another example, even if there's negatives involved, look, 5 minus 2i, same thing. There's the imaginary component, while here is the real component that goes with it. So, complex numbers it's a combination of the two. Now, there's a couple things that they do mention here that are very, we should mention them. They're a little noteworthy here. So it says, not all quadratic equations have real number solutions. For example, x squared is equal to negative 3 has no real solution. This is what we kind of saw the other day in our notes, where we took a square root of a negative value and we said, hey, that's not possible. So we just said no real solution. And it's because the square root of any real number is never a negative. But to overcome this problem, mathematicians created an expanded system of numbers using the imaginary unit I. So I will represent imaginary for us. And we already said that when you have I, it represents the square root of a negative. So just remember, if I is equal to the square root of negative 1, and if I were to give everybody a power of 2, look at what happens. We said this side would say I squared, while on the other side, a power 2 and a square root, they cancel each other out, leaving me with negative 1. And so from now on, anytime I see an I squared, we should never leave it like that. I squared actually becomes a real value, and our real value is negative 1. And so you can kind of see that here in the note on the side. These are a couple different powers that we can use with I, but these are the two most common ones we'll use for Algebra 2. But it's because of this concept of giving something a power 2 that we actually get a real number when I squared shows up. So from now on, I squared, we see it, we're going to write a -1 instead. So we'll replace it. Now, a couple examples here so that you can see, if you notice, they look a lot like the problems that we've already done in the past. Like yesterday or the day before, we said, hey, what's the square root of 49? Well, very easily, the answer would be 7. But as soon as that negative shows up and you try to throw this in a calculator, the calculator will say error. It'll say undefined, because we're not allowed to take the square root of negative values and get a real solution. But here's what we're learning. If I were to just pretend or ignore, that the 49 had the negative, right? If I split them up, well, now I can do the work. Look, the square root of 49, we know is just 7, but it's that negative that's kind of giving me a problem. So from now on, feel free to take the square root of a negative. The only catch is, as soon as you say it's a square root of a negative value, you bring out the I to let people know that this is not just any ordinary number. You took a square root, but it became an imaginary value because of this negative right here. That negative out here is what causes the I to come out. Let me show you again. See, now I'm going to do this a little bit faster. Because of this negative number, I need to make sure that when I write my answer, I'm writing the letter I, because I'm about to tell someone, hey, I'm taking the square root of a negative, so I'm about to give you an imaginary value. And now that I've done that, now I can just do the square root of 4, which is just 2. And just like that, I'm done with this problem. So the idea is, yes, we're going to do we're going to basically do everything we've learned so far about square roots. But if you're dealing with a negative value on the inside of a square root, we just have to let people know we are now in a new number system where we have imaginary values. Now, going on to the next one here, it says the square root of -45. Now, -45 is not a perfect square. And so we're going to have to bring in what we learned before. But I will mention, because of the negative, as soon as I start getting my answer ready, I'm going to leave a spot ready for that I. There, that negative is taken care of. I can almost pretend like it's not there. The only thing I'm going to worry about now is that 45, because that I is done. But that 45, we saw this the other day, we are not allowed to take a square root, so I'll break it down. To get a 45, that's 15 times 3. This is a prime number. A 15 is 3 times 5. These are prime numbers. So you see, we were talking about prime factorization the other day. So this would end up being 3 times 3 times 5. But we already said, when I get something like this, for every matching pair, one of the numbers comes out. And unfortunately, that 5 didn't have a matching pair, so it stays inside. Now, that's what we did the other day. The question is, how will I take this concept right here and apply it to this imaginary part here? Well, it's not much different than what we already did. Look, the I is for the negative. What gives me that 45? A 3 on the outside, a radical 5, so a 5 on the inside. So it's 3 radical 5. So this is one way of writing our answer, where we write the imaginary portion right in between. For those of us working with Big Ideas Math prefers the I to be here. There's a couple questions on there where if you put the I in the back, it's going to say it's wrong, even though it could be technically correct. So just be careful there with Big Ideas Math. All right, look, let's keep going. Just a couple more problems on this page. Now, this one has an outside value. We dealt with that the other day too. We said, if you have an outside value, well, then just leave it out there. Then I keep looking and I go, hey, there's a negative in there. All right, that's fine. I know how to handle that. That just means I'll put an I. And that part is done. So then the only thing left to ask about is, well, what about that 100? Well, that is a perfect square. We have an answer for that. the square root of 100 is just 10. Now remember, these numbers, it's not 210. They were right next to each other, so there's still some multiplication that needs to take place. But the 100 is there for the 10. The negative has now become the I. And when I multiply these two numbers together, so that's what I'm being asked to do, we end up with negative 20I. And there's our answer. Outside numbers get multiplied just like anything else. Think of it as if it just said x. Negative 2 times 10x would have been negative 20x. Let's try it again. We have an outside 6. All right. I'll put my times symbol this time right away. I do see this negative right here. So I'm going to have a spot for my negative. The negative just means I'm going to put an I there. And then, of course, I have the square root of 121. Well, the square root of 121 is just 11. So it's 11I. All I do now, simple multiplication. 6 times 11 is 66. But of course, we are now in an imaginary world here. So I need to make sure I put the letter I where it belongs. And then number 6 gets a little more interesting, just because the 75, as you can see here shortly, the 75 is not a perfect square. Doesn't change anything. You know what? I'm going to write it this way now. I have a 5. There's my times. I've got a negative value. So that's where, of course, I'm going to write my I there. No more negative to worry about. Then the only concern is that 75 that's right here. It's not a perfect square. So because it's not a perfect square, I'm going to break it down with our tree method from before. Let's see, 75, that is 5 times 15. That's already a leaf. The 15 is 3 times 5. Well, that's already a leaf too, 2 leaves. So that means I end up with 3 times 5 times 5. But for every matching pair, a 5 comes out, just one of them, and that radical 3 remains. So now I have to take this information and put it up there where my answer was to begin with. But just remember what we mentioned, especially with big ideas. If I ended up with 5 radical 3, yeah, I'm going to put the 5 there. But I'll put the radical 3 behind it. And we're not done. If you notice, we still had one more thing to do here. We still have to multiply the 5 with the 5. I know I got a little messy here. But 5 times 5 then becomes 25I radical 3. And just like that, there's my answer. Now, take a moment to catch up with the writing. If we need to pause the video, pause the video. So now that we practice this concept of the negative and how it turns into I, well, let's flip the page and see what we have on the other side. So let's read the directions first. It says, simplify the expression, then classify the result as a real number or imaginary number. But if the result is an imaginary number, specify if it's a pure imaginary number. Okay. Well, that sounds easy enough. All right, so here we go. Now, this is where you need to bring in your skills from your past. So if you notice, they said, all right, here's a complex number. Here's a complex number. But look at what they're asking you to do. They just said, add them up. Okay. If you remember the concept of combined like terms, that's exactly what's going to happen here. That's what they're telling me to do. I'm just adding. So, of course, I'm going to combine my negative 8 and my negative 1. They will be combined with each other. So that's just combining to a negative 9. And then, of course, I'm also going to combine my 3i with a negative 2i. Well, 3 minus 2 is just a 1. So this is just 1i. And just like that, we're done with this problem. Now notice this is still considered a complex number for a reason. So remember, this is what a complex number looks like. And the reason it's complex, we have a real component and we have an imaginary component. That's what makes it complex. We have a little bit of both. Even if it's an invisible 1, don't forget, there's still a 1 in front of it. It's still imaginary. Now, when I look at the next one, here's the only thing you have to watch out for. Even when you were in Algebra 1, you had to watch out for those minus signs because the minus sign just meant one thing. So here's the first thing you have to take care of for number 7, and that's the fact that you should distribute the negative or the minus, we'll say. So that's the first thing you should be doing. Little distribution there. Now the 36 minus the 3i, you don't need to write it in parentheses anymore. But when you distribute that negative, now it's negative 12. Negative times a positive is a negative 24i. And you see, now we're ready. I'm going to look at it carefully, and I'm going to combine the 36 with the negative 12. So that's 24. And of course, I'm going to combine the negative 3i and the negative 24i. So when I combine those two, we end up with negative 27i. So once again, we're already done because I can't put these two together. This is once again a complex number for the reason that we have the real component and the imaginary component. So you see, it goes back to what we already know. All right, so take a moment. We're going to pause the video here. Take a moment. Try number 9 and 10 based on what we just saw right now. So remember, as soon as I got it to this step, remember, all I did was combine again. But I had to distribute that minus sign first. All right, so let's pause the video and try number 9 and 10. All right, so let's see how you did on numbers 9 and 10 here. If you did this correctly, notice it's a straight combination because there's a plus sign. You should have noticed, though, that when you combine your 16 with the negative 16, well, they went away. But when you combined your I with your negative 8i, well, that reduces to negative 7i. And that's it. There's my number. So if you notice, I'm only left with an imaginary component. And if you're only left with an imaginary component, then this is what they call a pure imaginary. The fact that there's no real portion to it, only imaginary, nothing else. And then, of course, so you can check your number 10, you should have distributed the negative, the minus sign there. And when you have your negative 5 and your minus 5i, negative times negative is a positive 6. Negative times negative is a positive 6 again. Your combination here of the negative 5 with the 6 would be a positive 1. But your combination of negative 5i and your 6i would be a positive 1i. So we just say plus I. So yeah, this one continues to be complex for the reason that, remember, it's a complex number because we have a real component and an imaginary component. All right, getting close to the end here for this. All right, now, then we get to number 11 and number 12. If you look at number 11 and number 12, no, they are not adding them. They're not subtracting them. If you look right away, all we're doing is multiplying. This is what some teachers call the FOIL method, but in reality, it's just distributive property. So we are going to distribute here. That's the first thing we're going to do. All right, but when we distribute, we know we have to do this once. So that's negative 15. We have to do it 2 times now. Negative 1 times negative I is positive I. Remember, you're just multiplying. Treat it like an X. Don't worry that it's an I. 9i times 15. All right, we have a big number there. But 9 times 15 is positive 135. Yes, with an I, of course. Here's the one you need to watch out for. We're about to multiply 9i with negative I. So positive 9 times a negative is negative 9. But remember, I times I, we learned in Algebra 1, that would be I squared. Okay? Doesn't change the rules. We are going to combine these two like we've always done in our Algebra 1 days. So negative 15, 1i plus 135i is 136i, of course. Here's again where you have to be careful. Remember what we said earlier? We said I squared. As soon as you see it, so look, here's the negative 9 that's there. But when you see that I squared, we said you need to replace it with the negative 1. No longer an I anywhere on this. I squared is always replaced by negative 1 according to what we wrote on the other side. So now we have negative 15, 136i, but a negative times a negative is a positive 9. So by looking at it, now we have two real components. Well, of course, we're not going to leave it like that. We need to combine these two terms. Then we'll be done. Negative 5 and 9 is negative 6 plus 136i. And just like that, there's our answer. Here's the real component, while there's the imaginary, which is why this continues to be one of our complex numbers, because we still have a real and an imaginary component attached. But again, this is just very straightforward algebra concepts that we've done in the past. So when we look at number 12, I'm just going to slide it over so we can zoom in a little bit more. Here we go again. Look, we're going to multiply the 13 times the 13. Well, that's 169. 13 times negative I, negative 13i. I times 13, well, that's a positive 13i. And finally, here we go again. Watch out for those i's. Negative times a positive, negative. I times I squared. All right, if we look at the middle, we're going to combine like terms, but if you notice, this time it actually goes away. So that's good. Let's work for us. Less things to write. So that means I'm left with 169. But remember, yes, there's the minus sign. But we said, as soon as you see an I squared, notice that minus sign is already there. But as soon as you see that I squared, you should be writing a negative 1. Again, that minus sign is over here. This is the negative 1 for I squared. So then it's really 169 plus 1, so 170. And if you notice, this is just a real number. We ended up with a real solution. Even though we had imaginary numbers to begin with, it became just a real solution and nothing else. Now, we have added 2 more problems because of the assignment on big ideas. So take a moment to copy those. All it says is to solve. So here's where we're going to take what we learned in the previous lesson and adapt it to this new concept. If I'm solving for x squared, I get to use square roots here because it just says x squared. So I'm going to subtract the 25 from both sides. X squared is equal to negative 25. And of course, this is where I bring in my square root, because that's how we get rid of a power of 2. But remember, as soon as you do this, yes, you have an x. Based on the previous lesson, when you're solving for an x squared and you take a square root, you should have 2 possible answers. That's why we say plus or minus. Now we're going to do the work. I see a negative on the inside. Well, then guess what? That I is coming out. I see that 25. Well, the square root of 25 will go right here. The square root of 25 is 5. And this is where we say, oh, let's split the answer. Okay, so here we go. X is equal to 5i, and x is equal to negative 5i. Remember, that negative has no effect on the I. That I came from in here, has no effect with the negative that's down there. So that's us combining the two concepts from the previous lesson and today's lesson. All right, last one of the day. Here we go. I'm going to subtract the 1 because my goal is to isolate that x squared, leaving me with 5x squared is equal to negative 35. I'll divide everything by 5. I'm trying to isolate that x squared. So x squared is equal to negative 7. And of course, here we go. We take a square root of both sides. First things first, though, x is equal to plus or minus. And remember, because the negative is on the inside, I write the letter I. And since I'm not allowed to take the square root of 7, or sorry, we can't simplify a square root of 7, then we write the square root of 7 behind it. Remember, with big ideas especially, they want that radical to be in the back of the I. So that's why it's x equals I radical 7 and negative I radical 7. The work doesn't take long to do. You just have to be careful with these new little details that pop up. All right, with that said, make sure you're caught up with writing the notes and, of course, caught up with all your missing assignments. Have a wonderful day, and I'll see you next time for the quiz.